Hello friends, welcome again to my YouTube channel after a long gap. Actually, I was busy with some my other assignments, so I was not able to prepare video of my lecture. So, okay, now we'll start. In the last lecture, actually, we had seen about the different bases of selection. So, in that lecture, I had told you about the different bases. What are the bases on which the individuals are being selected? So, in that, just I had summarized that these are the different bases of selection. So, in which, if you remember last class, you can see that you have studied about the individual selection, pedigree selection, family selection, progeny testing, within family selection, etc. So, based on the weightage given to the PF and PW, we had decided that which kind of selection is this. Now, in that lecture, I had told you, I had discussed about the name of different bases of selection. So, here in this lecture, this is the second part of the lecture, basis of selection. So, in this lecture, we will see what are the different bases of selection, and we will see in some detail about the different bases of selection. So, first of all, let us start with the individual selection. First one is the individual selection. So, here what individual selection is? So, individuals are being selected on the basis of their own phenotypic performance. On the basis of phenotypic performance of individuals itself. Suppose you are having 10 cows. So, on the basis of the milk yield of cows, each and every cow, you have to record the milk yield of each and every cow, and the one who is giving highest milk yield, that individual will be selected. So, that is why the individuals are selected on the basis of their own phenotypic performance. And for that, to know the phenotypic performance, you can use either single record or mean of the several records. Suppose you are having 10 cows and you are having you are having full lactation milk yield record, daily milk yield record of all the 10 animals up to 1 lactation, that means 305 days or more. So, what you will do, we'll find out the average of all the records of a particular cow, and that is average of mean of the several records, or you can simply select on the basis of single record. So, in either way, you can know the phenotypic performance of the particular individual. So, you have to determine the phenotypic performance of individual, and it depends on you how you are determining the phenotypic performance of that particular individual. So, if you see the methodology or operating procedure, you can see it is the simplest to operate and yield rapid result. So, this method, because you just have to take observation and you have to rank the animals. So, this is very simple and it will give you very rapid result. It should used unless there are good reason for preferring another method. That means this is the most preferred method. And if you are using certain other method, then you must have certain reason why you are using another basis of selection. So, that means you have to prefer the individual basis of selection. It is preferred when heritability of the trait under consideration is high. So, this is the condition for individual selection. Why heritability of the trait should be high? You know, heritability decides whether a particular trait expressed by a particular individual or parent will be transmitted to its progeny or not. So, why we are selecting an individual? We are selecting an individual, we are choosing an individual. Why? Because we will give them chance to produce next generation. In hope of what? In hope of that that particular individual will produce similar kind of progeny. Or in simple words, if we can say that particular parent, how much milk is we are obtaining from that particular parent, we are in hope that same amount of milk will be obtained by the progeny produced by that particular parent. So for that, if that heritability of the trait should be high. So this is the condition for individual selection. The heritability of the trait should be high. Then it is done for trait whose records are maintained. So that means the first and foremost essentiality is that you should have record of the animal. If you don't have a record, you cannot select individual. You cannot form any basis of selection for that particular individual. So first and foremost thing for animal improvement, the first thing that we should convince to farmer to or a livestock keeper to maintain record of that particular or the individual or the animals that a particular livestock keeper is possessing. Now, what are the advantages? So, if you know what is individual selection, how it is being performed, then this what will be the advantage and what will be the disadvantage? This you can simply say. You can simply say. Just you have to think and you have to answer. So the first thing is that most useful for traits expressed in both the sexes. Trait expressed in both the sexes. That means there are certain traits which are not expressed in both the sexes. So what are those traits? The trait milk yield. So you know milk is not given by male animal. So that means individual selection, you cannot perform individual selection for male animal for milk production. Why? Because this particular trait is not expressed by a male individual. So this the individual selection is useful for trait expressed in both the sexes. The second, it is the only option in absence of systematic record keeping. When there is no record keeping of a particular animals, or there are no record keeping, there is a farm and in that farm there is no record keeping. So what you will do? How you will select individual from that farm? So you will just go, you will milk the animal, you will milk all the animals, and the animal who is giving highest milk yield, you will select. If you want to select for milk yield, or if you want to select for body weight, you just simply weigh all the animals, and the animal who is having highest body weight will be selected. So this is the only option when there is no systematic record keeping. Next point is all animals can be evaluated simultaneously. The beauty of this method, you can see what I told you. If there is no record, you just simply milk all the animals. So although you are selecting few individuals, 1 or 2 or maybe 4, 5, 10, but what you have to do, you have to evaluate all the animals. You will have to milk all the animals. So you will know the performance of each and every animal, though you will select only 1 or 2 individuals. So that means in this method all the animals can be evaluated simultaneously. Next point is, it gives an indication of high correlation between genotype and phenotype when heritability of the trait is high. So simply, if a particular trait is having high heritability, that means the parent, how much parent is performing, there is every chance that progeny will also perform, because the heritability of the trait is high. So if heritability of the trait is high, so in heritability also you have studied that it gives an indication of high correlation between genotype and phenotype. You might have studied RAP, correlation between breeding value and phenotypic value. Breeding value is genotypic value. So these are the advantages of individual selection. In similar way, you can deduce or you can figure out the disadvantages also. What are the disadvantages? So for traits expressed only in female, a trait which is expressed only in female like milk yield, individual selection is not possible for male animals. So if you want to select male animal for milk yield, It is not possible because male will not give milk. So that means then you have to look for certain other basis of selection. So that is why it is told earlier that if you don't have any other reason for preferring other method or other basis of selection, you have to opt for individual selection. Another condition is that characters that are expressed late in life. Characters that are expressed late in life. What are those characters? The characters which are being expressed late in life are the meat yield, carcass weight, carcass length. So these traits will be expressed after death of the animal. After death of the animal. So if you want to form the basis of selection, if suppose you are going for individual selection and you are willing to select that particular individual for carcass weight. So what you will have to do? You will have to first kill the animal, then you will have to see the weight of that particular carcass of that animal. But now suppose you decided, okay, this particular animal is having highest carcass weight. So you cannot go and select that particular individual because that individual has been killed by you for measuring carcass weight. So for such traits, you cannot go for individual selection. Then another is the traits having low heritability. Those traits which are having low heritability, you cannot go for individual selection. So these are the concept of individual selection, condition, advantages, disadvantages. Now another similar type of selection is mass selection. What is mass selection? Actually it is individual selection only, but it is another term used for individual selection. Why there is need of different term? Because in poultry and even in insect, in Drosophila also, in poultry here since I am associated with the animal breeding, so I will be telling you that in poultry, especially when the selected birds are put together en masse for mating. So here in large animal we are doing individual selection by selecting one or two individual, or individually we are picking the animal. But in case of poultry or laboratory animal, or you can say in insects, we are selecting whole lot of individuals. Maybe that lot contain 100 or 50 or 500 or 1000 individual in case of poultry or laboratory animal or insects. So whole lot will be selected en masse, means together. Whole lot will be selected together. So that is why it is called as mass selection. You are selecting in mass. So this was about the individual selection. The next one is the pedigree selection. So what is pedigree selection? I have already told you when I was telling you about the introduction of basis of selection. So pedigree selection is another basis of selection where we are selecting individual by seeing its pedigree. So what is pedigree? So pedigree is record of individual's ancestor that are related through his parent, and selection of individual based on such record is known as pedigree selection. What is pedigree? So pedigree is the record of individual's ancestor. So it is the record of not of individual but individual's ancestor. And which ancestors? Those who are associated with its parent. That means grandparent, great grandparent, great great grandparent, etc. And on the basis of records of pedigree, or on the basis of pedigree performance mentioned in that particular pedigree, we are selecting individuals. So such kind of selection is known as pedigree selection. So what we are doing here, selection based on pedigree information is determining the genetic worth of animal on the basis of performance of their ancestor. So it is similar to a condition where we are going to, for marriage, we are going to select male or female for marriage purpose. So what we are doing, we are just going and seeing the means suppose a person for marriage, he went to the bride or groom's house, and first of all he or she observe or get information about the bride or groom. After that, he or she will see about the pedigree of that particular individual, pedigree of the bride or groom. So why? In hope that if pedigree is good, that particular bride or groom will also be good. So here also, in case of pedigree selection, we are seeing the performance of pedigree, and we are hoping that since the pedigree is good or bad, so that particular individual will also be good or bad in that context. So pedigree selection importance decreases when information is available on individuals or family members. So why importance is decreases? Suppose the information is available on that particular individual or about the family member, its family members, then importance of pedigree is reduced. Why? Because in each generation, the common gene in each generation is getting reduced. In each generation, the gene is getting half. Only I may be transmitting half of my gene to my son or daughter. So in each generation, there will be halving of genes. So that is why if information is available on individual or its family members, then pedigree will be not of that much use. But there are situations where there is no information on individual or its family members. So in that case, we will go for pedigree selection. So now, just after understanding the pedigree selection, you just by yourself you can enumerate what are the practical difficulty. So what will be the practical difficulty? The first is the maintenance of record. In Indian condition, the livestock keepers in field condition, they are not maintaining record, or even if they are maintaining, they are not maintaining it properly, or even if they are maintaining properly, they are not keeping it they are not keeping ancestors record. Another thing is that if record is faulty, maybe due to stray mating. In India, the AI coverage, artificial insemination coverage, is also not up to the mark. So there may be chances of faulty stray mating. So if there is stray mating, the record maintenance will be faulty, and this faulty record will give you the faulty results. Then most of the characters have low heritability. So in pedigree selection also, the condition is that the heritability of the trait should be high. If heritability of the trait is high, then only the trait will be transmitting to the next generation. If it is low, there is less chance of transmission of trait to the next generation. So what will be the advantages? So advantages, it is very simple. There will not be any cost involved because you have to maintain only record. Only record keeping is necessary. Then it will allow selection at younger ages. Why? Because if family is pedigree is better, then there is we don't have to look for the individual's performance. So you can select even at younger age. Then good for multi-stage selection. Good for multi-stage selection. So what is multi-stage selection? This is assignment for you. You have to know, or you have to write in your notebook what is multi-stage selection, and how pedigree selection will be useful for multi-stage selection. It is very easy. Multi-stage name itself explain that selection at different stages. More detail you can find it in any text. Then another point is good for sex limited and trait expressed later in life. So just see, in case of individual selection, you were not able to select male for milk yield. Why? Because the trait was sex limited. But in case of here in pedigree selection, you can select male also for milk yield. Why? Because you don't have to see the performance of animal. You have to see the performance of its parents or its pedigree. its performance of its pedigree. So there is no need for looking, or it is applicable for sex limited trait. And then similarly, a trait expressed in latter part of life. That means even if animal is dying, you don't have to bother, because you have already selected an individual on the basis of its pedigree. On the basis of its pedigree. Then what are the demerits? So individual from particular pedigree can be culled in spite of having good genes. Likewise, some pedigree may get undue emphasis and favored. So suppose that the distribution of gene, or gene, a particular parent is giving gene to his progeny, is completely random. There is no control. There is no control of anyone on that. So whatever gene a particular individual is receiving from its parent is completely random. So there is chance that although pedigree is very good, but that particular individual has received very poor quality of gene. So in that case, we will be unduly emphasizing individual whose pedigree is better, and there can be vice versa also. So in many circumstances, pedigree may get undue emphasis. Then it introduces non-random bias, as records are of different environmental condition. So this is also very important. Generation interval in case of large animal, particularly in cattle, it may be 7 year, 8 year, 10 year. And if you have to see the performance of pedigree, that means you have to go back grandparent, great grandparent, great 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 grandparents. So that means almost 25, 30, 35 years back. So those individuals who has performed 35 years back may not find same environment as of now. So what we are doing, we are seeing the record of different environment and selecting individual in different environment. So this variation in environment may hinder the selection process. So it will introduce non-random biases. There will be biasness. It is not applicable for individuals having same pedigree. Suppose there are two brother sister or two brothers. You have to select out of these two brothers. You have to select one. So you cannot do pedigree selection for that thing. Why? Because both these two brothers will have same pedigree. So pedigree selection is not applicable for individuals having same pedigree. Okay, hope it is clear to you. Individual selection and pedigree selection. Now, the third one is family selection. Family selection. Family selection here, in family selection, we are focusing on collateral relatives. Collateral relatives. So those relatives that are not related to an individual directly, either as ancestor or as their progeny. Example, half-sibling, cousins, etc. So what are the collateral relatives? Those who are not directly related with the individual. That means they are either not directly parent or they are not direct progeny. So such what are those collateral relatives? Example is half-sibling, cousins, etc. So this was about the collateral relatives. Now in family selection, what we are doing, we are selecting whole family. Whole of the family we are selecting or rejecting, either selecting or rejecting as unit. We are selecting whole of the family as unit. It will not happen that you will select few individual from one family, few individual from other family, or few individual from yet another family. It will not be like that. But what will be there? You will have to select all the individuals of a particular family as a unit according to the mean phenotypic value of the family. So what you have to do, you have to first find out the mean phenotypic value of the family. You just see in the next slide how to find it. Then individual values are not used in determining the family mean. Individual values are only used. That means what is the use of individual value when we are going for family selection? So with the help of individual value, we are finding out the family mean. So we'll see in the next slide how we are finding out the family mean. So this was about the family selection. In the family selection, on the basis of mean phenotypic value of the family, those family which are having highest mean phenotypic value, whole of the family will be selected, and those who are having lowest mean phenotypic value of the family, the whole family will be rejected. So what are the conditions? Now here you have to note that the family selection, the condition for family selection is it require low heritability. Why it require low heritability, we will see in the next slide. It requires low heritability. Mean value of number of relatives provide a more reliable guide to breeding value than individuals' own phenotypic value. So what is the concept of family selection? It tells that individual's own value will be individual's own value will be less better in comparison to the mean value of whole of the family taken together. Why? Because the family members are somehow related with that particular individual to which you are going for selection. So all the family members might have get some common genes, and we have to identify those common genes. So this family selection will be very helpful in finding out those superior quality common genes. So this is based on the concept that individual's single genotype will be better if we are taking the mean phenotypic value of whole of the family. So another condition is that larger the family, closer is the correspondence between the mean phenotypic value and the mean phenotypic value. So it states that when there is larger family, that means more number of individuals are there in the family. So in that case, mean phenotypic value will be equal to mean genotypic value. Why? Why it is like that? Suppose a particular grandparent, that means grandfather and grandmother. So from that grandparents, total 9 progenies are being produced, or 9 or 10 progenies are being produced. You know, the transmission of gene is completely random. So suppose by chance one particular individual got very superior gene. Another particular individual got very inferior gene. Then yet another individual got optimum gene. Then again very good gene, again very poor gene, again very good gene. So ultimately what we will do, we will find the mean of all this phenotype. So mean of the phenotype, so many in some individual it is superior, in some individual it is inferior, in some individual it is optimum. So this superiority and inferiority will be cancelled out, and this mean phenotypic value will give an actual idea of what superior gene parents were possessing. That means this mean phenotypic value will be almost equal to the mean genotypic value or genotypic value of that particular family. Why? Because deviations are being cancelled out. So that is why it is written that if the larger the family size, if suppose there are 20 individuals in a family, then there is every chance that mean phenotypic value will equal to mean genotypic value. Why? Because the randomness will be cancelled out. Then another, consider the intensity of selection. If the family size is large, intensity of selection will be also large. Why? Because you will have to select few individuals from that. If there is large number of family, you have to select one family. So intensity of selection will be high, and there will be less chance of inbreeding also. If there is small family size, there will be chances of inbreeding. Then if you see, this is the family. Suppose this is family 1, family 2 and family 3. So what you will do, suppose this family, what we are doing, suppose this animal is giving 6 liter milk, this is 5 liter, 4 liter, 3 liter, 5 liter, 6 liter. So by adding all this milk yield performance dividing by the total number of individual, we got the mean of F3 family as 6 liter. Similarly for F1 family 4 liter. F1 family 4 liter. Similarly F2 family we got 8 liter. So what we will do, the mean of the F1 is 4 liter, F2 is 8 liter and F3 is 6 liter. So on that basis we will select the F2 family. F2 family. So this is about the family selection. Now you see, what is the environmental deviation? The environmental deviation of the individual tend to cancel each other out in mean value of the family. So what we have already discussed in the last slide. Suppose this animal is having 6 liter because of influence of environment. This particular individual is having 4 liter. That means environment was negative for him. For this animal it was positive. Again it is 5 liter optimum. Here 2 liter negative environment. Here 8 liter very positive environment. So this deviation, suppose mean is 5 liter. So this deviation 5 minus 6 1 liter, then 2 minus 5 minus 3 liter, then 8 minus 5 3 liter. So this all deviation will be cancelled out from each other, and this will give you the idea of the mean genotypic value of that particular family. So if the family is large, the mean phenotypic value will be equal to the mean genotypic value, or it will be similar to the mean genotypic value. So this environmental deviation will be getting cancelled out. So this is the importance here. That is why in case of, suppose here the environmental deviation is large, that means heritability will be low. If environmental deviation is large, because you can see the definition of heritability, H square is equal to Vg by Vp, and Vp is another made of two component, Vg plus Ve, that means environment. So if environment is large, that means heritability is low. So that is why I have already told you the condition for family selection is that it requires low heritability, and if there is high heritability, the family selection will not work. So you will have to go for either individual selection or pedigree selection. Then the next now the advantages of family selection. What are the advantages of family selection? So just similar, if you have understood the concept of family selection methodology, then you can answer this question: what are the advantages of family selection? So you can see, you can select individual at early age. Why? Because you are seeing the family, whole family you are selecting. Either this whole family include the progeny also. So even a newborn baby will also be getting selected if you are performing family selection. Then similarly, the traits that are expressed in only one sex. Then third, it supplement individual selection for lowly heritable traits. So you know the condition for family selection is that the heritability of the trait should be low. So when you are getting a low heritable trait, you may go for family selection. Then what may be the disadvantages? So disadvantage is the common environmental effect. Because if there is common environmental effect, heritability will be high. So if heritability is high, you cannot perform family selection. Then next one is the small family size. So we have already discussed, if there is small family size, there will be chance of inbreeding and intensity of selection will be less. Intensity of selection will be less. Another disadvantage is that it is costly of space and time. So if you have to select whole of the family, you have to maintain large number of families. So maintaining large number of family, particularly in case of large animal, it is very difficult. At a time you cannot maintain large number of families. So this was about the family selection, and similar to this family selection is the SIB selection. What is SIB selection? So in case of family selection, we have already discussed that in family selection we are getting the mean of the family. How we are getting mean of the family? We are summing of performance of all the individuals and dividing it by the total number of individuals. So suppose total number of individuals is n, and you got the summation x. So summation x by n is equal to mean of the family. Now in case of SIB selection, you don't have to include the observation of that particular individual. You have to include the observation of all the relatives, but not of that particular individual. So here just I will read out. Some characters cannot be measured on the individuals. So why it is necessary? Because many a times the character is not measurable in that particular individual. Suppose you are going to select male animal for milk yield. So in that case, you cannot get performance of male animal with regard to milk yield. So you have to exclude the observation of male animal with regard to milk yield, and you have to get the mean of all other relatives or all other family members. So in that case, this SIB selection will be helpful. This is actually a family selection, but with the difference that now the selected individual have not contributed to the estimate of the family mean. So the individuals which are being selected, which have to be selected, the information of that particular individual you don't have to include in the calculation of mean. So this is very helpful in sex limited trade or the slaughter trade, the animals which are to be slaughtered. So if there is slaughter of animal, you will not have observation of that particular individual. So in that case, you can go for SIB selection. Okay. Now similar to the SIB selection is the last one is the within family selection. So you have to remember the family selection, SIB selection, and within family selection. These all three are related, but there is some significant difference between all these three. So many a times in examination you will get questions on the basis of differences between these three methods, and if the differences is not clear, it will be very difficult to find out the differences between these three. So what is within family selection? Within family selection, deviation of individual performance from the mean of the family to which it belongs. Suppose this is just see here, there are three family, F1, F2 and F3. So suppose F1 family mean is 8 liter, F2 family mean is 10 liter, and F3 family mean is 7 liter. Now suppose I am looking for the F1 family. In F1 family, this particular individual, this particular cow is having 6 liter of milk yield. So how much it is deviated from mean? So 8 minus 6, that is 2 liter. Another individual, you see here the milk yield of this particular individual is 10 liter. So what is the observation? 8 minus 10, that is minus 2 liter. That means this particular individual is superior to its family by 2 liter. Another individual, suppose it is 12 liter. So 12 minus 8, that is, or 8 minus 12, that is minus 4 liter. That means this particular individual is having 4 liter superiority over its family. So why this superiority is there? This superiority is there because they are family members. That means they are having common ancestor. So they got same set of genes, but this particular individual performs very well. Why? Because the distribution of gene from parent to progeny is random. So due to this random nature, this particular individual might have received superior quality of gene, and that superiority we have to exploit. We have to exploit to get better progeny from this particular individual. So this is the concept of within family selection. Now just I will read the few sentences that I have written here. The animals that exceed their family mean, already these points I have discussed. The animals that exceed their family mean by greatest amount are considered to the most desirable, and that particular individual will be selected. This method is advantageous over the other. Why it is advantageous? Because the large component of environmental variance common to members of the family. So you have to look where the large environmental variance are common to a particular family. So just see the example of pig. So in case of pig, one mother pig is giving birth to almost 10, 12, 15 progeny. So all these 10 or 12 progeny that particular mother is nursing, they are getting the common environment of mother. So even if they are getting common environment, but a particular piglet is performing well, that means that particular pig is having superior quality of gene. We have to identify that particular pig, and we have to select that pig to be propagated to the next generation. So this is the advantage of within family selection. So here large part of variation of individuals winning weight. In case of pig, I am talking about the winning weight. So a large part of variation of individuals winning weight is attributed to the mother and is therefore common to members of the family. But selection within family would eliminate this large non-genetic component from the variation operated by the selection. So here in within family selection, the individual who is deviating maximum from the family mean that particular individual will be selected. So in this way, let us summarize today's lecture. So today we have seen the different bases of selection. The first one was the individual selection, then pedigree selection. In these two, we have seen the condition that heritability of the trait should be high. Then the third one was the family selection. In family selection, the heritability of the trait should be low. Then there was the deviation of the family selection, that is shift selection, and within family selection. So with this, I am ending today's lecture. In the next lecture, we will be seeing certain other basis of selection like progeny testing, then combined selection, and many other things. So till then, just you go through the lecture and prepare your assignment and submit through the link given to you. Thank you.